them pronouns, and I am here to help you with this question. Now, what we have here is we have the sets M and we have the set N and we have the set P, which is equal to M union N. What does that mean? That means that the set P consists of all the vectors in the set M and all the vectors in the set N. So let's think of some vectors that are in M and some vectors that are in N, because if any vector is in M or in N, it's automatically in P because it's the union of both of those sets. So let's start with some vectors in M. So M, this is saying that M is the set of two-dimensional vectors with real numbers such that this bar means such that 0 is less than or equal to the x-coordinate, which is less than or equal to the y-coordinate. So we're looking for coordinates that are both positive or 0, right? Because 0 is less than or equal to the smaller coordinate. And the x-coordinate has to be less than or equal to the y-coordinate. So let's think of some examples of that. So maybe 0, 0 is an example, or 1, 4, or 2, 2 is an example, or 6, 7, maybe. These are all examples of vectors that are in M, because notice that all the coordinates are either 0 or positive. And the other thing is that the y-coordinate is always greater or equal to the x-coordinate. And how about for N? Let's think of some vectors in N. So some vectors in N, so N is the set of two-dimensional vectors with real values. That's what this first part means, such that, the bar means such that 0 is greater than or equal to the x-coordinate, which is greater than or equal to the y-coordinate. In other words, both of the coordinates have to either be 0 or a negative number. And also, the x-coordinate now has to be greater than or equal to the y-coordinate. Not like M, where x could be less or equal to. Now, x can be greater than or equal to the y-coordinate. So let's think of some examples. So 0, 0 is also in N, interestingly enough. But also the vector -2, -5 is in N. The other one that's in N is -6, -12. That's an example of one that's in N. Another example is -6, -8, right? So the y-coordinate is smaller than the x-coordinate. Another example would be -1, -3, right? So what do we have in all of these? We have that the coordinates of all these vectors in N are negative or 0. That's the first thing. And we have that the y-coordinate is always less than or equal to the x-coordinate. Now, let's try to find a couple vectors from our list here that if we add them together, because all of these are in P. So if we add them together, are we going to get something that's not in M and that's also not in N? In other words, that's not in P. Are we going to get that? Well, actually, taking a look at this, I see this vector 2, 2, which is in P, and this vector -1, -3 is in P. But if we add them together, we get 2, 2 plus -1, -3. The way we add these vectors together is we add the components together. So we add the x components. 2 plus -1 is 1. 2 plus -3 is -1. Now this is not in P. Because notice that the criteria for both the sets M and the sets N was that the coordinates have to have the same sign. But over here, 1 and -1, 1 is positive and -1 is negative. So this is an example. And you can think of other examples this way.